Hi students! In this video, we're going to learn how to find the solutions to an equation using the graphical method. Supposing I have a curve represented by y equals to negative x cubed over 2 plus 3x plus 2 and a straight line y equals to 10 minus 3x. We can see that the straight line intersects the curve at two intersection points, one here and the other one here. So what do the x coordinate of these two intersection points tell you in regards to the equations of the line and the curve? Yes, the x coordinates of these two points, these two intersection points, are actually the solutions to the line and also the solutions to the curve. How can we verify it? We can substitute x equals to 2, y equals to y equals to 4 into the straight line and the curve. And let's see if it satisfies both functions. So for the straight line, when I substitute x to be 2, I have 10 minus 6 equals to 4, which is the value for the y coordinates. So therefore, this point 2, 4 satisfy the equations of a straight line. How about the curve? When I substitute your x to be 2, I have negative 8 divided by 2, that gives you negative 4 plus 6 plus 2, and that gives you 4 also. So therefore, this point 2, 4 satisfy the straight line and also the curve. You can do it for the other intersection point here, and you will see that it also satisfies both functions. So other than this point satisfying the line and the curve, do you think if there are other equations, where the intersection point, the x coordinate of intersection point actually satisfy the equations? Are there other form of equations you can think of? Yes, how about this one? If you were to equate the curve equals to the straight line. Let's see from here if we can show another equations. So I'm going to multiply by 2 throughout. And I'm going to put all the terms on the left-hand side. Right, you will see that we actually end up getting a cubic equation. And if you were to solve this cubic equation, I'm just going to use the calculator to help us do it. It's the easiest way, fastest way, more efficient way. Oh, the values, the coefficients of x squared is 0, 1, 0, negative 12, 16. Yes, we will have x equals to negative 4 and x equals to 2. So the two values are clearly the two x coordinate of our intersection point. So do you think there are other forms of the equations that would have this solution x equals to -4 and x equals to 2? In other words, I can actually form a lot of variation, right, using this cubic equation, right? I can write it as x squared I can divide by x throughout to get x squared minus 12 plus 16 over x equals to 0. So this particular equation will also give me x equals to -4 and x equals to 2 as a solution, right? I can also write it as x squared minus 12 equals -16 over x. That means I can have a quadratic curve intersecting a hyperbola curve, right? And I'll still get the solution x equals to -4 and x equals to 2, right? So what I'm trying to say here is that there are various ways of drawing the curve and the straight line from here. And I would still get x equals to -4 and x equals to 2 as a solution, right? Right, so using the concept we have learned just now, if I'm given a cubic curve y equals to 6x cubed minus 10x minus 1, what do you think will be the equations of a suitable straight line that I can draw on the same axis to solve this equation? So from the earlier slides, I understand that I would have to do something to this equation, right? Make it such that something is equal to something. And what is a something on the left-hand side would be my equations of the curve. Which is your y equals to 6x cubed minus 10x minus 1. And what is on the right-hand side would have to be the equations of the straight line. The suitable straight line that you need to find. Y equals to something. Okay? Right, so this is what we need to do. So from 6x squared minus 4 over x equals to 12. In order to get the equations of the curve, which is a cubic x to the power 3, we see that I have to multiply x to every term. And then I would get 6x cubed minus 4 equals to 12x, right? And then I'm going to, I need a negative 10x here. So I'm going to subtract on both sides, right? And then I need a -1, which means I need to add 3, right? So that I would end up having 6x cubed minus 10x minus 1 equals to 2x plus 3. So therefore, this 2x plus 3 would be the straight line, the suitable straight line that I need to draw on the curve here. Okay, so to draw the line y equals to 2x plus 3, what is it that I need? Yes, I need a table of points. So I can just let x to be 0, and then y will be, coordinate will be 3. I can let x to be 1, my y coordinate will be 5. So with 0 and 3, 1, 2 here, and 1, 5, and you can use a straight line to draw your suitable straight line. Okay, I can't do it properly here. All right, and you'll see that this 3 intersection point, right, will be the solutions. The x coordinate of this 3 intersection point will be the solution to this equation 6x squared minus 4x. 6x squared minus 4 over x equals to 12. So this will be the suitable straight line that I need to draw. Right, so I hope this video can help you to understand how we can form a suitable straight line to solve any equations that's given in the questions graphically.